Yeah. So we'll left with a small topic. उसके बाद we'll have to go for the collisions के बारे में जाएंगे, आज ही जाएंगे. Conservation of linear momentum. Conservation of linear momentum. You know already done linear momentum का questions. Okay. इधर conservation of linear momentum का कैसे करेंगे देखो. So what is the condition for conservation of linear momentum? याद है condition क्या है? When we have to apply conservation of
When
momentum?
no external forces.
External force 0. Now since we are talking about system of particles का, पूरा system of particles का net force should be 0. In that only we can apply the conservation of momentum for total system only. Okay. So net force, that external force is 0. Then only we can apply conservation of linear momentum. We know the formula, right? F is equal to delta P by delta T. Net is also system का. Because particles है ना, system का पूरा system का conservation of momentum लगाना है. Now external force is 0. लगाया तो कितना होगा? Delta P is equal to 0. So that means final momentum minus initial momentum equal to 0. Therefore, initial momentum is equal to final momentum. This is for total system का. हेवी सिस्टम है, हेवी सिस्टम है. बिकॉज पार्टिकल्स कितना भी होने सभी का मोमेंटम लेने का. दिस इज कंजर्वेशन ऑफ मोमेंटम. कंजर्वेशन ऑफ मोमेंटम विल बी satisfied only when external force is 0. And we done on that in Newton's laws of motion में gun and bullet का we done, right? Gun will exert a force on bullet at the same instant में bullet also will exert a force on gun. So action reaction pair, they are equal and opposite, they cancel out each other, so there is no external force. That's why we are applying conservation of momentum. And initially body is at rest मान के चल के we are putting initial momentum is 0 लगा के solve करता था. Okay, चलो. Now इसमें आपको famous examples कौन सा है? Simply आपको कौन सा है? बॉम्ब ब्लास्टिंग क्वेश्चंस ओनली. ओके, बॉम्ब ब्लास्टिंग क्वेश्चंस ओनली. फेमस का कैसे करेंगे? ओके, एक्सप्लोजन ऑफ द बॉम्ब. ओके, सो क्वेश्चन के थ्रू लर्न करेंगे. क्वेश्चन पढ़ो, अंडरस्टैंड एंड ट्राई टू सॉल्व. इजी वन मेथड ओनली. ओके, ए बॉडी ऑफ मास 5m mass is there at rest, explodes into 3 fragments of the ratio 3:1:1 ratio में split होगा. This 5m is splitting into this masses 3:1:1. Okay, 2 of the fragments of mass m are found to move at a speed of 18 mutually perpendicular direction. So दो masses are moving at a speed of 18 meters per second perpendicular to each other. The velocity of the third fragment will be, okay, देखो, one mass like this, one mass like this. 1:1:3 means what is the ratio? Tell me. 1:1 1:1 ratio means, so 3m mass है, एक 1m mass है, and 1m mass है, right? So what is saying? 2 fragments of each mass m वाला are moving perpendicular to each other. He is asking third fragment. Third fragment किस तरफ move होगा compulsory? आपको
Resultant.
So won't it be in terms of I cap, J cap?
Answer should be no, value बोलो.
Okay.
क्या करेगा?
Yes, 1 minute.
So initially there is no external force, bomb blast हो रहा है ना, there is no external force, internal force की वजह से only blasted, so we can apply conservation of linear momentum. Initial momentum of system is equal to final momentum.
Here I got 6.
No, wrong. Total velocity of the third ball.
So should we consider the first 2 balls as one system?
देखो, नहीं ऐसा नहीं है. Initial momentum equal final momentum, right? Initial momentum is how much? System का. It is rest. Initial momentum total all particles are rest. Blast नहीं हुआ. Initial momentum 0.
So I got
Now,
root 72.
Root 72 means 6 root 2. Yes, correct. ओके, नाउ देखो इनिशियल मोमेंटम, इसका मोमेंटम कितना होगा? mv1 mv2 दोनों स्पीड इज 18. बाद में सब करेंगे. mv1 mv2 इन दोनों का रिजल्टेंट फाइंड करो पहले. नेट रिजल्टेंट बाय यूजिंग पैरेललोग्राम लॉ. नेट फाइंड करो एंड दैट इज इक्वल टू दिस साइड, दिस फोर्स इक्वल करो हो जाएगा. इन दोनों का रिजल्टेंट कितना है? mv1 mv2 अंडर रूट get us and v1 equal v2, right? They told same speed, v1 equal v2, so कितना होगा? अंडर रूट 2m v1, right? तो मैं नेट रिजल्टेंट अंडर रूट m v1 होल स्क्वायर प्लस m v1 होल स्क्वायर, so root 2 m v1. okay, that is equal to this one. Simply equate this side momentum को this side momentum, हो जाएगा. करो कितना आएगा? Because net momentum should be 0, right? So simply equate this side momentum with this side momentum. So क्या है? आपको क्या करेंगे? Simply shortcut है. तो इस तरफ वाला root 2 m v1 is equal to 3 mv. Because here momentum mass into velocity, mass into velocity, mass into velocity we are doing, right? Equate करो, mm cancel. So v1 के जगह में कितना होगा? 18 है, is equal to 3v. So it's 6. So v is equal to 6 root 2 meters per second. So मैं always आपको बॉम्ब ब्लास्ट में क्या करेंगे? आपको नेट रिजल्टेंट का मोमेंटम इज इक्वल टू द अदर मोमेंटम. Why this side only it will flow, it will go? Because initial momentum is 0, right? So final momentum blasting करने के बाद भी momentum का resultant should be 0. देखो blasting करने के बाद इन दोनों का resultant is this direction, and the third body will move in the opposite direction only compulsory to cancel the this momentum. Okay, understood, right? Yes, करो. The explosion blows a rock into 3 parts. 2 parts go at right angles to each other. These 2 are 1 kg. First part moving with velocity 12 meters per second, and 2 kg second part moving with velocity 8 meters per second. Okay. The third part flies with a velocity 40 meters per second. The mass of the third part is how much?
So this, oh, okay.
Kgs are given, right? M1, M2 is given. M3 का M ले लो and solve. Since they are going at right angles, उसको cancel करने के लिए, हाँ?
Theta will be 45 only, right?
Theta is 45 degrees.
Resultant.
देखिए.
Sir, I got 0.5.
Yes, correct. तो शॉर्टकट क्या है? इसका मोमेंटम का रिजल्टेंट फाइंड करो, दैट इज इक्वल टू इसका मोमेंटम करो, हो जाएगा. One kg, it is moving with 12 meters per second. So इसका मोमेंटम is mass into velocity 12, and इसका मोमेंटम कितना है? 2 kg, it is moving with velocity 8. So इसका मोमेंटम will be
Is it half? 0.5.
0.5. yes. So 16 मोमेंटम आया, इसका 12 मोमेंटम आया, इसको पैरेललोग्राम लगाए तो अंडर रूट 144 plus 256. So it is 420, right? That is equal to m3 v3, right? 20 is equal to m3 v3. So कितना होगा? m3 is equal to 20 by 40. So it's 1 by 2. So 0.5 kg. So मैं आया? चलो. Now इसमें करेंगे मॉडल में. आई करो. Like same model only, but in terms of velocities में पहले वाला क्या था? In terms of displacement में center of mass change नहीं हो रहा है वाला. But always with respect to ground से करो. So a man of mass m, small m, moves in a plank of mass capital M. A capital M में plank का mass है, he is going with velocity, इसका mass है m है, is moving with initial velocity u. With respect to plank, okay. When the plank rests on a smooth horizontal surface, determine the velocity of the plank. Definitely when he moves like this, the plank velocity will move in the backward direction. So asking what velocity say it will move. So उसको capital V ले लो and find the value of V.
So will you get answer in terms of mu?
In terms of U में आएगा. U small m capital M में आएगा. So direction sign conventions we should take care of properly. And so
So if it rests on a horizontal surface, the initial is 0, right? If it lies on a horizontal surface, the initial momentum is 0, right?
Yes. So initially the momentum will be 0. Because ये walk कर रहा है, ये is applying a force on this and same instant में he is also applying, the plank also applying the force on him. So there is no net force, we can apply conservation of momentum. But with respect to ground से करो आ जाएगा. So initial momentum is always equal to final momentum. So 0 is equal to initial momentum of man का देखो is going from here to plank rest on the
So
small
is
surface.
it mu by capital M?
No wrong. देखो small mass into velocity, right? देखो velocity कितना velocity से is moving now, इसका momentum कितना है? Initial momentum equal final momentum, right? Final momentum taking. देखो
mu by m
इसका
plus
speed
n.
u minus v, right side positive, left side negative, right? So इसमें क्या होगा? m times of u minus v. That's a convention. We're applying conservation of momentum. Initial momentum is at rest. Final momentum सभी पार्टिकल सिस्टम का अप्लाई करने का. इधर दो पार्टिकल्स आर देयर. One is man and one is plank. दोनों को मोमेंटम में ऐड करने का, राइट? सो इसका मोमेंटम कितना? m इंटू u माइनस v, ओके, प्लस इसका कैपिटल M इंटू कितना आएगा, बोलो कितना लगाने का?
V minus U.
नो रॉन्ग. अरे विद रिस्पेक्ट टू ग्राउंड के रिस्पेक्ट में
Only V.
हाँ,
Only V.
माइनस v. राइट साइड पॉजिटिव, लेफ्ट साइड नेगेटिव ऑलवेज. ओके, नो करो. नो फाइंड द प्लैंक वेलोसिटी, कैपिटल V फाइंड करो. mu minus mv minus capital MV. So equal 0. So is a minus v अगर मैं कॉमन लूंगा, m plus m.
So small mu by M plus capital M.
Small mu by m plus capital M. No, second one you know already. करो. If the man travels a distance L with respect to plank, now man is traveling from here to total distance with the plank. Find the distance traveled by the plank with respect to ground. ये मान लो x distance travel किया plank when he walks. Asking what is the value of x?
So if the man moves, how can the plank also move?
Definitely, right? Because frictionless है ना. अगर बोर्ड मान लो इधर जा रहे तो पीछे आएगा ना, ऐसे ही. So initially center of mass is at rest. Final also center of mass is at rest.
So you have to use a m1 dx on that one.
Plus m2 dx2 equal 0. खत्म.
Sir, both the m will be capital M only, right?
Why? दो पार्टिकल्स का है ना, दो पार्टिकल्स है, मैन का एक प्लैंक
So it will be m plus m, okay.
Sir, I got m into L plus x by m.
x I want.
So m
Oh.
into L by m plus m.
Yes, correct. m1 dx1 plus m2 dx2 equal 0. So m का man का now कितना distance travel किया?
I got
He traveled L distance, but the plank went x distance, right? So right side positive, left side negative. So L minus x plus a plank का mass m, a distance traveled is in this direction, negative direction, minus x equal 0. So ml minus small mx
So won't it be L
minus
plus x?
L plus x, no? Why?
So because
He
distance
is
of
going right side, length and the plank is moving left side.
oh plank left.
Because definitely normal लगाया. देखो answer negative आए तो indirectly you have to understand that if you put like same direction also, Answer will be negative. That means you have to understand that Planck is going opposite direction, which we assumed. So m l minus x common है तो m plus m equal 0. So either है तो minus minus cancel. So x is equal to ml by m plus m. Understood?
Sir, won't the L minus X be for capital M plus small m, right?
M into L minus x.
No, sir, why is it only small m and not capital M also?
देखो ये x का always we are taking with respect to ground. We are assuming the Planck is moving x distance with respect to ground, but a man is moving what? देखो a man of mass m moves on a plank of mass with a constant velocity with respect to Planck.
Okay, sir.
Is only person with respect to Planck only, but always we are assuming bottom wala always with respect to ground wala. So एक frame of reference से only total problem you have to solve. Okay, चलो. So these are the conservation of momentum वगैरह पूरा आपका हो गया है totally. Next we have to start with a collisions.
So
Okay.
that's it for this chapter.
1 minute. Collisions हम लोग start करेंगे.
So can you give one more linear